Okay, in this video, you are going to learn the important parts of frequency distribution. After you created this distribution, you have to know some of the important parts. The first one is called lower class limits. There are two class limit value you can see, lower class and upper class. The lower class means each class interval. If you see the first value, this is called lower class limits. So you have to know how to identify the lower class limits. That's the first thing you have to know. The same way, upper class limits. So the top value, that is called upper class limit. So let's see what are the upper class limits for this particular frequency table. That is easy to identify. Next value, you have to know class boundaries. The class boundaries means when you see this class interval, they are mutually exclusive. That means disjoint. There's no connection in between these two values. This is the end and the starting value, 69, then move to 70. There's no connection in between that. If you want to create the histogram or the frequency polygon, you have to know what are the class boundary values. Then only we can connect those two bars. So that's the reason I'm going to show you how to find out the class boundaries, middle of the end value and the beginning value. Find out the middle of that is called class boundaries. For example, in between 69 and 70, that is 64.5. So that is called the class boundary values. Same way you can find out for each class, we can find out the class boundaries. In order to that, you have to know what is previous value for 60 and after 129. There are two extra boundary values you have to know before 60 to 69 and after 120 to 129. So these are the values we call the boundary values. This you have to know how to calculate this. This one is most important part for your histogram. Next, class midpoints. That is also another important part. If we want to create the histogram, sometimes we can use the class midpoints to create. Midpoint means that's easy to calculate. What's the mid value in between 60 and 69? Simply go and add 60 plus 69 and divide it by 2. That will give you the mid value of 60 and 69. The same way 70 and 79. You can see the mid values of each class intervals. Class width. Now, without knowing the class width, if you know only the class intervals, using that also, you can find out the class width. If you pick two lower class intervals or if you pick two upper class intervals, if you subtract, that will give you the class width. For example, 70 minus 60, 10, 80 minus 70, 10. Or we can pick two upper limit values, 99 minus 89, 10 or 109 minus 99, 10. Everywhere you can see the class width is 10. So here is an example. You can try yourself, find out the frequency table, then identify lower class, upper class, class limit and the class width. Right. Now the steps. How to construct a frequency table manually. The step number 1, divide on the number of classes your frequency table will contain. Mostly we have to use the number of classes in between 5 to 20, not too big or not too small. Next, determine the class width. So if you want to determine the class width or number of classes, you can apply this formula. For that, first you have to find out what's the range. Range equal highest value minus lowest value. Then using the class width, we can apply this formula, range divided by number of classes Or if you want to find out number of classes, you can divide range divided by class width. Next, select as the lower limit of the first class either the lowest score or value slightly less than the lowest score. Compute the class limits. Add the class width to the starting point to get the second lower class limit. Add the class width to the second lower class limit to get the third class limit, and so on. That's the way you can find out each class limits. Number 5. List the lower class limits in a vertical column and enter the upper class limits. The last one, find the total frequency for each class. So total frequency always match with the total number of data. So here's another example. You can try yourself and find out. So for this one, the frequency table provided, you had to identify lower and upper class limits, class boundaries, class midpoints, and class width. So large data set can be summarized. The reason why we are using frequency distribution, I already explained to you in the beginning, large data set can be summarized. Or we can analyze the nature of the data. We have a basis for constructing important graphs. For that, we had to know the frequency table. So here's an example. Read the question carefully and identify which one is the right answer for that. So second example. Few more examples. The answers also provided. You can check yourself and write. Next, so you have to know after you create your frequency table, there are two values you have to know how to calculate. One of them is called the relative frequency distribution. No worries, we have a formula for that. So relative frequency distribution equal class frequency divided by number of all frequencies. Or if we want to calculate the relative percentage, so you had to times by 100%. If you want to write as a fraction, or if you want to write as a percentage, times by 100. So here's an example how to calculate the relative frequency. So frequency table, I'll show you one example how to calculate the relative frequency for the first one. 60 to 69, we have a frequency of 12 divided by the total frequency 40 times 100, that will give you the percentage, 30% for the first one. Same way, you can calculate the rest to find out the relative frequency distribution. Next, the cumulative frequency, that is just the adding numbers. For that, we can write this as a 60 to 69 or less than 70. Both represent the same. So in between 60 to 69, the first value always same as 12. So 12 means 12. So number 2, 70 to 79 or less than 80, you have to add this value with the previous one. For example, 14 plus 12 equal 26. For the next one, 80 to 89 or less than 90, 11 plus 14 plus 12. Or simply you can add 11 plus 26 equal 37. And so on, you can calculate the cumulative frequency distribution. So you can see all in one, there are 3 tables represent frequency, relative frequency and cumulative frequency. So here's an example. Right. The critical thinking, interpreting frequency distributions. After you create your relative or the frequency table, how you can show them in the table. For that, we are going to introduce the histogram. Before the histogram, you had to know normal distribution. Later on, you are going to learn what is a normal distribution mean. Looks like a bell shape. For example, starting from the lowest, go and get the peak point and go down to the lowest. So the shape like a bell. So that is called the normal distribution. So you can see the frequencies start low, then increase to 1 or 2 high frequencies, then decrease to a low frequency. Or the distribution is approximately symmetric, with frequencies preceding the maximum being roughly a mirror image of those that follow the maximum. When I show you the graph later, you see how to identify is it normal distribution or the skew to the right or the left. So here's an examples of normal distribution. You can see this shape as the bell. So you can see in the middle line, you see the symmetric about both lines. So that's all about in this video. So I'm going to explain to you the rest on the next video. Thank you.